Welcome back to Dumb Down Tech. So, you'd have seen in a previous video, I finally got my arse in gear and built that ITX gaming PC that I've been talking about for a little while. Don't like any related videos, there will be a link in the description below. So, in that video, I did say I was going to do a little follow-up, as by the time I built it, I was a little bit tired, a little bit stressed. So I thought, you know, we'll have a little look how we got on after the testing. So I've kept the testing quite straightforward and limited it to Cinebench for CPU performance and Heaven for GPU performance. We'll have a little look at kind of out-the-box default settings and what could I achieve in an ITX system with a bit of an overclock. So with that being said, let's get into it. Starting with our CPU in Cinebench, our Ryzen 5600G at stock settings running at 4.4 GHz managed a Cinebench R23 score of 10,980 with a CPU max package temperature of 71 degrees Celsius. The CPU cores maxed out at 70.5, and on the power side the CPU package pulled in 68.93 watts and the cores 59.39. In the middle we're looking at our 30-minute run at stock settings, so still running at 4.4 GHz. We produced a score of 10,860, so a little bit lower, but to be expected running at the higher temperatures. The CPU package temp maxed out here at 77.8 Celsius, the cores maxed out at 77.4, and this time round pulling slightly more power with the package pulling in 73.02 and the cores pulling 63.98. Over to the right hand side, and here we go with our overclock, a little bit ridiculous. So this time we're running at 4.75 GHz and this produced a Cinebench score of 11,718, and the CPU package temp maxed out at 99.1 Celsius with the cores maxing out at 98.8. The package pulled 108.33 watts and the cores pulled 95.63 watts. Moving over to our percentage difference graph, using our stock single run as our baseline, you will see for the stock 30-minute run our score reduced by 1.1%, our package temperature increased by 9.6%, our core temperature increased by 9.8%, and we pulled 6% more on the package and at 7.7% more with the core wattage. On the overclock single run, our score did increase by 6.7%, but unfortunately to the detriment of our package temp, which increased 39.5%, our cores increased by 40.1%, and we pulled 57.2% more package watts and 61% more watts on the cores. Now for our GPU Heaven runs. On the left you'll see our stock run, so no overclock applied. We produced a score of 2,500 with a Heaven average FPS of 99.2 frames per second, a max FPS of 207.4, a minimum of 36.6. Our GPU package maxed out at 70 degrees and our hotspot maxed out at 81.9 degrees Celsius. On a 30-minute run, our package temp maxed out at 76 degrees and our hotspot maxed at 87.3. Moving to the center, using the bundled software with the graphics card, we did a overclock auto scan setting, which then overclocked the card by 126 MHz on the clock and 200 MHz on the memory. This produced a Heaven score of 2,609 with an average FPS of 103.6. A maximum FPS of 216.2 and a minimum of 38.8. The package max temp here reached 75 degrees Celsius and a hotspot temperature of 87 degrees Celsius. On a 30-minute run, the package temp got up to 79.2 degrees Celsius and a hotspot max of 91.1. Over to the right hand side, we did a manual overclock, so we increased the clock by 200 MHz, the memory by 375 MHz, This was all I could manage to do without it crashing, and this produced a Heaven score of 2750, with a Heaven average FPS of 109.2, a maximum FPS of 228.1, and a minimum of 39.8. This produced a GPU package max temperature of 77 degrees Celsius with a hotspot temperature of 88.2. On a 30-minute run, the package temp rose to 80 degrees Celsius and the hotspot rose to 91.5 degrees Celsius. Now over to our percentage difference, again using our stock settings on the GTX 1070 Ti as our baseline. We will see on the OC scan settings, our score improved by 4.4%. Our average FPS also improved 4.4%, with our max FPS going up by 4.2%. Minimum FPS increased by 6%. This did result in a package temp increase of 7.1%, a hotspot temperature increase of 6.2%. On the 30-minute run, the package temp increased by 4.2% and the hotspot temperature 4.6. Under this, we've got our manual overclock, and this produced a score increase of 10%, with an average FPS increase of 10.1%, max FPS increase of 10%, minimum went up by 8.7%, and the package temperature rose 10% as well. The hotspot temperature increased by 7.7%, and on the 30-minute run, the package temp increased by 5.3%, and the hotspot temperature by 4.8%. In conclusion, am I happy with the performance of the system? Yeah. It performs as I was expecting. I was very pleasantly surprised how cool the system actually runs, considering the very limited cooling that's in it. I mean, so we've got a low profile cooler with a 120 fan, a 120 fan above that, and then just two slim 120 fans pushing air in for the graphics card. So very pleased with how well the system performs firmly. Going forward, where I finally managed to put this system, after a bit of faffing about, I did manage to find a bit more space. So I am now thinking, after trying to, the bit of overclocking and seeing what you can get out of a system when you've got some more thermal headroom, I'm thinking of maybe changing the case out, keeping the bulk of the components, maybe swapping the graphics card out, because I'm in no way jealous that Chris has managed to swap his 1080 out for a 6600 XT. And when we did some testing on that, I may have got a little bit jealous, but anyway, that's beside the point. It's purely about getting the best out of the system. So in future videos, we'll see what I managed to come up with, because I need to somehow shut Chris up for being smug. I'll see you in the next one.